odd and even numbers. For example, if you look at odd numbers 1, 3, 5, 7, 9, 11, and so on, they increase by 2 continuously. And if we give examples of even numbers 2, 4, 6, 8, 10, 12, and so on, they also increase by 2 continuously. So the first group is odd numbers and the second is even numbers. Now we can express odd numbers generally as 2n minus 1, where n must be a natural number. On the other hand, even numbers can be expressed as 2n, where again n must be a natural number. Let's take a look. We take an arbitrary small natural number n, which belongs to the set of natural numbers we previously mentioned. For example, if we take n as 1, then 2n minus 1 will be equal to 1, and 2n, it will be equal to 2. Indeed, for any given natural number n, 2n minus 1 is an odd number and 2n is an even number. These are the odd and even natural numbers. It's possible to perform operations on odd and even natural numbers. First, let's start with addition and subtraction. Addition and subtraction. We can add two odd numbers and the result will be an even number. For example, if we add 3 and 5, we get 8. And 8 is an even number. The same happens when subtracting two odd numbers. For instance, when we subtract 3 from 5, we get 2, which is indeed an even number. We can also add or subtract odd and even numbers. For example, adding and subtracting 5 and 4 will result in 9 and 1, both of which are odd numbers. Next, we can add or subtract two even numbers. For instance, if we add or subtract 4 and 2, we will get 6 and 2, both of which are even numbers. Thus, the sum of two even numbers are always even, the sum of odd and even numbers are odd, the sum of two odd numbers are even. Now, let's look at the multiplication operation. Now, we can multiply two odd numbers together, and the result will always be an odd number. For example, 3 times 5 is 15, and indeed it's an odd number. Or if we multiply 7 by 3, we get 21, which is also an odd number. Similarly, when we multiply two even numbers, the result will always be an even number. If we multiply 4 by 6, the answer will be 24, an even number. If we multiply 8 by 2, we get 16, which is also an even number. Next, we can multiply an odd and even number together. For instance, 3 times 4 equals 12, an even number. 5 times 2, 10, and 10 is also an even number. Thus, the product of odd and even number is always even, the product of two even numbers is even, and the product of two odd numbers is odd. Now, let's move on to exponentiation. When we talk about exponentiation, what do we mean? It means multiplying the number a by itself n times. For example, 3 multiplied by 3 multiplied by 3, and so on. If we multiply 3 by itself n times, we can write this in short form as 3 to the power of n. Now, if we raise an odd number to the nth power, the result will still be an odd number, where the n must be a natural number. And let's take a look. 5 to the power of 3, this means multiplying 5 by itself 3 times, equals 125. We can see that 5 to the power of 3 is an odd number, so 5 was an odd number and its nth power is also an odd number. Or let's look at another example. 3 to the power of 4 equals 3 times 3 times 3 times 3, and which equals 81, right? 3 was an odd number and 3 to the power of 4 is 81, and which is also an odd number. When we raise an even number to the nth power, the result will be an even number, where n must be a natural number. Now, for example, 4 to the power of 2 means 4 multiplied by 4, and this equals 16. 4 was an even number and 16 is also an even number. Indeed, this statement is correct. Or if you take 2 to the power of 9, 2 to the power of 9 means multiplying 2 by itself 9 times. This equals 512. 2 was an even number and 2 to the power of 9 is also an even number. So, this is exponentiation with odd and even natural numbers.